going to walk through a solution to reversing an integer. This is a positive integer in C++. So before I get started, there's a couple of different ways to do this. More than a couple. There's ways to do it involving strings. There's ways to do it maybe a little bit faster in terms of execution speed than what we'll do on this video. But the reason I want to show you this way of doing it is that it's just kind of taking a reliable strategy for coming up with an algorithm. This is the type of problem that, at least initially, might not feel like sort of just like a pattern recognition type thing or pattern generation type problem, but it can be turned into it, and a lot of problems can be. And so, first off, before I get started with anything like this, I try to set up a little bit of a testing platform. So, rather than constantly running the program and typing in a bunch of user inputs, I want to be able to just run the program and test a whole bunch of inputs and outputs that I know the answers to, right, and see if my code is generating them correctly. So in main, I just call test for a couple of numbers, right, and I know what to expect. My test function, there's nothing fancy going on here. All it's doing is printing out the number. It's calling reverse, and it's printing out the reverse number. So it's just kind of showing me what the progress is. Now, right now, reverse just returns the value, so it's not doing anything, really all that useful. But I just set the program up like this, so I can run the program, and I know, I've got my inputs and my outputs. Obviously, my first number is already correct, right? But I have to focus on the other ones. So first off, whenever you've got something that you can visualize as a function where you have some inputs, specific input with a well-defined output, you want to try to test it in isolation like this, and don't write your code so you got to keep typing in the inputs, right? Just write your code so it just runs and you can visually inspect it. Even better, if you know what the test cases are, you can write some if statements and you can say like the test passed, the test failed, that kind of stuff. I didn't go that far. All right, so let's look at what's happening here. And in order to reverse these things, I know that I'm going to have to pick off each individual digit. I'm going to have to do something for every single digit. And as soon as I start to say that, out loud, I realize, okay, well, I'm doing something for each something else, right? Each digit in this case. So ideally, I'm going to have a loop that goes around and does something, don't know yet, but does something once for every single digit. And I need to come up with, if I'm going to do that, I need to come up with a general way of figuring out how many digits are in these numbers. Whatever value is, how many digits are there? And in the CMath library, there's a log10 function, which takes the log base 10, basically telling you how many digits there are. Right? So I can get a feel for how that's going to work just by using that function call. And I'm just going to print out digits. Okay, so digits comes out as 0, then 1, then 239 is 2. So digits is sort of 1 behind, which kind of makes sense, right? The 10 to the 0 power would be 1. So it makes sense that maybe we need a plus 1 there to get it exactly right. Right. So I have the number of digits, the number of times around a loop that I'm going to go, and I can start the loop. But the question is, now what am I supposed to do on every single iteration of this loop? For that, I can start to think, how can I mathematically define these numbers? So let's just take the 932. Right? So we've got a 9, we've got a 3, and a 2. All right. Now I'm going to eventually figure out how to visit this maybe in the opposite order, but for now, let's just, we can just keep it like this. Let me write these in comments so I can keep them in the code once I start building. This is going to be 200. This is going to be 30, and this is going to be 9. All right, and these are going to be added together. So I'm just going to be adding these each time around. All right, so those are the numbers. If I add 200 plus 300 or plus 30 plus 9, I'll end up with 239. Right? So I actually did it reverse, right? So if I added, my input was 3932, I would have been doing this. Right? If it was 2, 3, and 9, right, it would have been 2, 900 plus 30 plus 2 to 932. So you see how if I can find the individual values here, I can transform them into numbers that I'm going to be adding, and I can turn this into an accumulation problem. So the trick is going to be, how do I get these numbers? Right? How do I get those numbers? So first time around the loop, I mean, I can just maybe take the least significant value. Okay, let's just start off like that. How do I get the least significant value of 52 or of 239 or of 3954? Well, I could do value mod 10, right? And that would give me that. I'm just writing a little code, just doing a little exploration, right? So least significant figure of 9 or digit of 9, that's good. Least significant of 52, yeah, that makes sense. Now I went around twice there and I printed out 2 both times. And that makes sense because I'm taking value and I'm not changing it in any way. So the next time around the loop, I just did value mod 10 again. So I didn't get the right number on the second time. Same thing's happening over here, right? The first time around a loop, I get the right number. The second time, the third time, not so much. Same thing for the 4,000, for thousands. So now the next question we ask, well, how do we make this work every time around a loop, right? Obviously, value isn't what we need to take the least significant figure of every single time. It's value the first time, but after that, it needs to be somehow changed. Again, go back to your test cases, right? How do you find those values? The first time around, let's take this value. The first time around, we have 932, right? We mod 10, right? And we get 2. Right? The next time around that loop, I want to be able to find the number 3. So I don't want value to be 932 anymore. I want value to be 93. 93 mod 10 will be 3. So how do I transform the 932 into the 93 becomes the question. Well, what I could do, and I'm going to use a temporary variable. So let's just call it number value. Right? I don't want to change the input value, even though it's probably not it's not going to hurt me right now. I'm not sure whether later on down the road I'll still need the original value. But what I could do is I could say number equals number divided by 10. All right? If I took 932 and I did mod 10, I'd get 2. And then if I took 932 and I divided it by 10, I would get 93. Integer division, right? It would work out nicely. Let's do some additional printing here. Before we change number, I want to print it out just so I see it. And let's explore. Let's see if it works. Oops. Got to get rid of my little notes there. Oh, so I changed. I went through this business of using number, but I didn't change it over here. Okay, so now what do I got? All right, so value to reverse is 9. All right, so the reverse value is 9. That's fine. Notice I got 2 and then I got 5. Right? For 239, I got 9, 3, and then 2. For 3954, I've got 4, 5, 9, 3. I've got the right numbers. The least significant figure is right every single time around that loop. That number is not as important anymore, I guess, right? Let's get rid of that because it's maybe a little bit distracting. I got 9, I got 2 and 5, right? I've got 9, 3, and 2. Those are the values that I needed when I was coming up with this math over here. But now I need some sort of a factor. Each number is going to have to be multiplied. So for 239, for instance, the 9 was getting multiplied by 100. The 3 was getting multiplied by 10. Every time around that loop, I'm using a different factor. Let's print the factor out. The factor for the first digit is just 1. Every time around the loop, factor is going to be multiplied by 10. And let's print out a factor. And let's see if they're matching up right. I've got 9 with a factor of 1. I've got 2 with a factor of 1 and 5 with a factor of 10. Okay, that's not quite right, actually, right? So 9 with a factor of 1. No, that should be 100, right? So that should be 100. That should be 10. That should be down to 1. So they're going in reverse direction, those factors, right? I want to get something better. If that's the case, then what do I start factor at? I'm going to be dividing by 10 each time. Right? Well, I know that there's some number of digits, right? I want the first number to be 1 if digits was coming out to be 1. Right? So what I could do is I could take the power 10 digits minus 1. It's not a surprise digits minus 1 is the opposite of the log 10 plus 1 here. Right? So now I've got 9 with a factor of 1. I've got 2 with a factor of 10. 2 times 10 will be 20 plus 5. That looks good. And then down to 1. Now I've got the 100, the 10, the 1. Now I've got the 4,000. I've got the 500, 90, and then multiplied by 1. Now I've really just turned this into an accumulation problem. I'll set an accumulator rev for reverse, set it at 0. And I'm going to say, just going to accumulate the least significant figure times the factor. Right? That's the numbers that I'm printing out here. And at the end, I'm not going to return value. I'm going to print out. I'm going to return rev. Nine reverse is 9. 52 reverse is 25. 239 reverse is 932. 3954, 4593. I got it. I didn't come up with any real sophisticated math here. I could definitely make this go a little faster. I could maybe avoid using a logarithm that is a little bit expensive to do. But I got this working, right? And I can remove some of the printouts now. And that's really all I need to do here. I'll leave that as an exercise for you to try to figure out how you can do this algorithm a little bit differently, not to have the logarithm. I'll give you a hint. You need to instead of necessarily thinking about only accumulating in rev, you want to sort of be taking away from value, and you'll know when to stop when value gets too low. So that's kind of the hint for that. But this will get the job done.